Okay, so in this video we're going to look at the next topic, which is called collisions. And in the collisions topic, well, it's all got to do with collisions, basically, where you have one sphere collides with another sphere, and basically what happens to their speeds once they collide. In the cases we're going to look at today, we're going to look at impacts, which is where one sphere falls on the floor or impacts with a wall or something like that. So there's a couple of new concepts today that I'm going to go through fairly quickly, but I hope you've kind of seen them before, things like kinetic energy and momentum. But I'll go through them really quickly, but if we need to go back over them and go into them in a bit more detail, we can. So what's this topic about? Well, in today's lesson, basically, we're going to talk about, let's say you have a sphere, and that sphere is falling towards the ground. And let's say just before it hits the ground, it has a speed of 20 meters per second. Bounces off the ground, hits the ground, and then it starts to move back up. In all the questions we've done so far, we assume that no energy is lost. We assume that when it bounces, hits the ground, it comes back up to the same height that it fell from. So what that implies is if it hits the ground at 20 meters per second, because it goes back up to the same height, it implies that it bounces back up at a speed of 20 meters per second. Now actually, because the 20 meters per second is in two different directions, I could say, well, this is the minus direction and this is the plus direction. So this has a speed of minus 20 meters per second in the j direction. This has a speed of plus 20 meters per second in the j direction. Now, in reality, that doesn't happen. In all the questions we've done so far on other topics, that's kind of what we've assumed. But in reality, that doesn't happen. In reality, what happens is you drop a ball, and let's say it's hitting the ground at minus 20 j direction meters per second. It bounces back up and it doesn't get quite as far as the height that you dropped it from, which implies that when it bounces off the ground, it has lost some of its speed. It might now only have a speed of 15 j meters per second, and the plus is because it's in the opposite direction. So what happened? Well, energy was lost. Where was that energy lost? Well, when the ball hits the ground, it makes a sound, so some energy is lost as sound. When the ball hits the ground gets a little bit warmer, the ball gets a little bit warmer, so heat is generated, so as lost energy is heat. So let's say we did this on a wooden floor and this was the reaction we got, or this was the change in speed. If we did exactly the same thing, we got exactly the same ball, and we dropped it from the same height so that its speed was minus 20 j meters per second on a carpet floor, would its upward speed be the same? Well, no, you'd assume that its speed might be a bit different. It might be 10 j meters per second. Why? Because carpet is different to wood, so obviously there's going to be a different amount of energy lost. The amount of energy that's lost depends on this quantity or variable known as E, and E stands for the coefficient of restitution. And in this case, in the first case, the ball only retains 3/4 of its original speed, or 3/4 of its original kinetic energy, so the coefficient of restitution would be 3/4 because it kept 3/4 of its original speed. In this case, the ball kept half of its original speed, so the coefficient of restitution would be a half. And this value of E changes depending on what type of surface the ball is dropping on, and also what the ball is made out of. Is it a leather ball? Is it a plastic ball? A slitter? All those things affect it. So E basically tells us how much of its speed it still has after it hits the surface. And E must always be between 0 and 1. If E is 1, it means it has its complete speed. It has not lost any speed. Not lost any speed. And this type of collision, the collision between the ball and the surface, we call perfectly elastic. Whereas if E is 0, basically it means it has lost all its speed. And we say that that is an inelastic collision, or perfectly inelastic collision. So E basically has to be between 0 and 1, and that's an important fact to know when we go on to the higher level questions especially. So that's the main gist of it. So we look at an example. Now this example is from the book. You have the Foldens book on page 110. Oh, sorry, one last thing. I've basically done these numbers are easy. I know that E is 3/4 and E is 1/2, but the equation that you can use to figure them out is that V over U equals minus E. And that's the equation I want you to learn today, or one of the equations I want you to learn today. So if we do that for, say, the first example, V stands for final velocity. So the final velocity is 15. U stands for initial velocity is minus 20 equals minus E. So 15 over minus 20 is minus 3 over 4 equals minus E. Therefore, E equals 3 over 4, which is what we got in that question. So that's the equation that you're going to use. So make sure you write that one down in your notes. Now let's look at an example quickly. Page 110 of your Foldens book. So we have a football mass 2 kg is falling vertically towards the ground. So here's a football falling towards the ground. It's immediately before impact, its velocity is minus 12 j, so that's before the impact. The coefficient of restitution is 2 over 3. Find the speed of the ball after impact. So find the speed here. Well, before impact is u, so we're basically looking for v, its final velocity. Our equation was v over u equals minus e. So we're looking for v, u is minus 12, and e is 2/3. So don't forget the minus there, it's equal to minus 2/3. Multiply both sides by minus 12. They cancel, and we're left with v equals minus 2/3 multiplied by minus 12. A minus and a minus is going to give us a plus. 24, so 8 meters, 8j meters per second, and the j is just the direction there. And you notice that we get a plus answer because now it's moving in the opposite direction. Plus j on the way up, whereas it was minus on the way down. So that's part 1. Part 2, find the impulse imparted on the ball by the impact. So impulse is something you haven't seen before. So the equation for impulse is mv minus mu. And we'll talk about what it kind of means in another lesson, but basically it's the change in momentum. And you probably haven't seen momentum yet, but you will come across it if you do leave insert physics, and we'll come across it a lot more in this. So if they ask for the impulse on the ball, it's going to be the mass of the ball, which was 2, times its final velocity, which we figured out was 8, minus the mass of the ball, which is 2, times its initial velocity, which was, now here's where you have to be really, really careful. It's not 12, it's minus 12. So make sure you put in that minus, because otherwise your answer will be wrong. So 2 times 8 is 16, minus 2 times minus 12 is minus 24. So we have 16 minus 24 is 16 plus 24, which is 40j. Now the unit for this is Newton seconds. So actually make sure you learn that. The unit for impulse is Newton seconds. And again, we will come back to this, but at the moment I'm just going to give the equation. So that's the second equation you need to learn from today, impulse. The last part of the question is the football's loss in kinetic energy. Now I'm hoping that you've come across kinetic energy before. Something has kinetic energy if it's moving, and the equation for kinetic energy, hopefully you've seen before, is a half mv squared. Now loss in kinetic energy, K is how we write kinetic energy, would be its initial kinetic energy, take away its final kinetic energy, or before kinetic energy, take away after kinetic energy. So how much kinetic energy had it before? Well, if this is our equation, the kinetic energy it had before would be a half times its mass, which is 2, times its velocity, which was minus 12. squared. Now it's just a v squared bit, so that minus 12 is squared, so that's going to become a plus. Take away its final kinetic energy is a half, 2, sorry, depends on that, times its final velocity, or its kinetic energy afterwards, which is 8. Its velocity was 8, which is 8 squared. So type that into your calculator and you get 144 minus 64, and that gives you an answer of 80, sorry, the pen's gone, 80 joules. So kinetic energy is energy, so its unit is joules. And I think you've come across this equation before, so hopefully that's alright. 3 equations to learn today. You have this one, V over U equals minus E. You have this one for impulse, and then kinetic energy, which is one that I'm hoping you've seen before. But if not, let me know.